So we just, in the last page, generated a second probability formula, which is the probability of A given B. We've already talked about our addition rule to find the union of two events, and this is a screenshot of what's given on your reference sheet. So you actually get both of these formulas to use. On the last page, we also did the probability of B given A. And even though we don't have that on here, we can apply what we see. So we see that when we do conditional probability, we need to do the probability of the second thing. So in this case, that would be the probability of A. And then on the top, we have the intersection of the two, which we know is commutative. So I could just put that here. So what I mean by commutative is I could also read B and A here, right? And it would be the same thing. So here is our first one. We are given the probability of B, the probability of A and B, and the probability of A given B. So, sorry, not given, but I need to find this. So if I look at my two formulas, I can tell I need to use the second formula because I have information related to that. So the probability of A given B is equal to the intersection probability over the probability of the second thing, which is B. So we're getting these actually to the nearest thousand, so 3 decimal places. So this is 0.857. I take that in. So if we know B is true, the probability of A is 0.857. So here's another one, and we have 3 probabilities now, and we're asked to find different things. So we know probability of A, probability of B, and the probability of their union. So once I see the union, I know I'm going to have to do something with that top formula, at least to start out. So if I want the probability of A and B, nothing yet is talking about a conditional probability, so I'm using the first formula. So the probability of A union B, which is 0.874, equals the probability of A plus the probability of B minus the probability of A and B. So I add these two up, do some subtracting, do some solving. This is going to give me 0.37 plus the 0.80. I get 1.17 minus P of A intersect B. And over here, 0.874. I'm going to get some room. So basically, I'm going to subtract the 1.17. And that's going to give me negative 0.296. And if I start to get this pattern, I don't have to do the next step, which is divided by -1. I can just kind of drop the negative on both sides, but I do get 0.296 here. So now that I've found that, there's something I can use for other problems. So my next one says I want the probability of A given B. So looking at this formula, I need the intersection probability, which I just found. And I need to divide by the probability of the second thing. So that from the top, the given information is 0.80. So when I type that in, that gives me 0.37. For probability of B given A, I am going to have on the bottom now probability of A, which is 0.37. And in my numerator, I have the intersection, right? A and B, which I have over here, which is 0.296. So this is 0.8. I'll put 0.0, but that's basically what the probability of B given A is. And we already talked about how they're not going to be equal to each other in most cases. And we can see we got 2 different answers for B and C. Our last question, we have some different information. So we have P of B, P of A given B, a union, and a P of A. So I'm going to rewrite the formulas here just so we can use them. And this one is a little all over the place. So my first rule is my addition rule. Because I really want to look and say, okay, like, what do I have and what can I use here? Minus P of A and B. A given B is P of A and B over are my two formulas. So I'm going to check off stuff I have. So they told me what P of B is. They told me P of A given B. And they told me P of B. So this one I have two unknowns. So I can't really use that one yet. But in this one I only have one unknown. And I see that this unknown will help me use the first formula and get towards the thing I really need. So I'm going to start with a conditional probability formula. So P of A given B equals P of A and B, which is something I don't know, over P of B, which is 0.20. So I am going to multiply on both sides by 0.20, cancel this out. So I get 0.14 for P of A and B. So now I'm ready and I can use my first rule because now I do have this piece of information. So P of A union B, 0.78 equals P of A, which is the thing I'm trying to find, plus P of B, which is 0.20, minus the new value I found, which is P of A and B, which is 0.14. So simplifying this or getting towards solving it, P of A plus 0.06. So then I just need to subtract from both sides, and I'm going to get that P of A equals 0.72. In terms of checking these, I can always go back through and just make sure both formulas work with all the values I found, and that's a good way to check them. And just a comment, when you're starting out with probability, when you use a two-way table, you have a much better idea of what's actually going on and what you're finding. These formulas, just like we do in math a lot, is if you're doing some sort of applied problem, you're working in a health field, a business field, and you just quickly want to find the chance of something, the formulas are just a fast way to use them, but we do kind of lose the feel of what's going on when we use them. But as I said, they have their positives and negatives.